Grounding bushings are essential components in electrical systems, primarily serving to establish a low-resistance electrical pathway to ground. This pathway is crucial for safely managing electrical faults or surges, thereby protecting both equipment and personnel from potential damage or injury. The fundamental purpose of a grounding bushing is to provide a secure and reliable connection to ground, ensuring that any unintended electrical current is quickly and safely diverted away from sensitive equipment and human contact. Grounding bushings find their application in several key scenarios within an electrical system. Firstly, they are used when an electrical system is connected to a grounding electrode. This grounding electrode typically takes the form of a grounding rod or a grounding plate, which is buried in the earth to establish a direct connection to the earth's potential. The grounding bushing, in this case, facilitates a low-resistance connection between the electrical system and this grounding electrode. This low-resistance connection is vital because it allows fault currents or surges to dissipate rapidly and efficiently into the earth, preventing them from causing damage to equipment or posing a shock hazard to individuals. Without a properly installed grounding bushing in this scenario, the effectiveness of the grounding electrode would be significantly diminished, and the risk of electrical hazards would increase substantially. Secondly, grounding bushings are employed when an electrical system is connected to a neutral conductor. The neutral conductor plays a crucial role in maintaining the voltage balance within an electrical system and is typically grounded at the service entrance or the distribution panel. The grounding bushing, in this instance, provides a low-resistance connection between the electrical system and the neutral conductor. This low-resistance connection is essential for maintaining the system voltage at a safe and stable level. By ensuring that the neutral conductor is properly grounded through the grounding bushing, the system voltage is effectively referenced to ground potential, preventing voltage fluctuations or imbalances that could potentially damage equipment or create hazardous conditions. Thirdly, grounding bushings are utilized when an electrical system incorporates surge arresters. Surge arresters are specialized devices designed to protect equipment from the damaging effects of voltage surges, which can be caused by lightning strikes, power grid switching, or other transient events. The grounding bushing, in this case, provides a low-resistance connection between the surge arrestor and the grounding electrode. This low-resistance connection is critical because it allows the surge arrestor to effectively dissipate any surge currents that may occur. When a voltage surge is detected, the surge arrestor diverts the excess current to ground through the grounding bushing, preventing it from reaching and damaging sensitive equipment. Without a properly grounded surge arrestor, its ability to protect equipment from voltage surges would be significantly compromised. In summary, grounding bushings are indispensable components in ensuring the safety and reliability of electrical systems. Their primary function is to provide a low-resistance electrical path to ground, which is essential for dissipating fault currents, maintaining stable voltage levels, and protecting equipment from voltage surges. The three main scenarios where grounding bushings are typically used are when connecting to a grounding electrode, when connecting to a neutral conductor, and when connecting to a surge arrestor. In each of these scenarios, the grounding bushing plays a critical role in ensuring that the electrical system is properly grounded and protected from potential hazards. The importance of grounding bushings cannot be overstated, as they are a fundamental element in safeguarding both equipment and personnel from the dangers of electrical faults and surges. Proper installation and maintenance of grounding bushings are essential for ensuring the continued safety and reliability of any electrical system. When selecting a grounding bushing for a specific application, several factors should be taken into consideration to ensure that it is appropriate for the intended use. Firstly, the size and type of the conduit or enclosure to which the grounding bushing will be attached must be considered. Grounding bushings are available in a variety of sizes and configurations to accommodate different types of conduit and enclosures. It is important to select a grounding bushing that is compatible with the specific dimensions and material of the conduit or enclosure being used. Secondly, the ampacity rating of the grounding bushing must be considered. The ampacity rating indicates the amount of current that the grounding bushing can safely carry without overheating or failing. It is important to select a grounding bushing with an ampacity rating that is sufficient to handle the maximum fault current that the electrical system is likely to experience. Thirdly, the material of the grounding bushing should be considered. Grounding bushings are typically made of copper, aluminum, or a combination of both. Copper is a highly conductive material that provides excellent grounding performance, but it is also more expensive than aluminum. Aluminum is a lighter and more cost-effective alternative to copper, but it may not provide the same level of grounding performance. The choice of material will depend on the specific requirements of the application and the available budget. Fourthly, the type of grounding lug or connector used with the grounding bushing should be considered. Grounding lugs and connectors are used to connect the grounding conductor to the grounding bushing. It is important to select a grounding lug or connector that is compatible with the size and type of grounding conductor being used. Additionally, the grounding lug or connector should be made of a material that is compatible with the material of the grounding bushing to prevent corrosion. Fifthly, the installation environment should be considered. If the grounding bushing will be installed in a corrosive or hazardous environment, it is important to select a grounding bushing that is specifically designed for use in such conditions. These grounding bushings are typically made of corrosion-resistant materials and may have additional features such as seals or coatings to protect them from the elements. In addition to selecting the appropriate grounding bushing for a specific application, it is also important to ensure that it is properly installed. Proper installation is essential for ensuring that the grounding bushing provides a reliable and effective connection to ground. The following steps should be followed when installing a grounding bushing. Firstly, the surface of the conduit or enclosure where the grounding bushing will be installed should be cleaned and free of any dirt, grease, or corrosion. This will ensure that the grounding bushing makes good electrical contact with the conduit or enclosure. Secondly, the grounding bushing should be securely attached to the conduit or enclosure using the appropriate hardware. The hardware should be tightened to the manufacturer's specifications to ensure a secure connection. Thirdly, the grounding conductor should be properly connected to the grounding lug or connector on the grounding bushing. The grounding conductor should be sized according to the applicable electrical code requirements. Fourthly, the grounding connection should be tested to verify that it is providing a low resistance path to ground. This can be done using a ground resistance meter. The ground resistance should be as low as possible, ideally less than 25 ohms, as specified by the NEC section 250.53. This section covers the ground impedance measurement from the farthest point in the branch circuit back to the source or service ground. If the ground resistance is too high, the grounding connection should be inspected and corrected. In addition to proper installation, regular maintenance is also important for ensuring the continued effectiveness of grounding bushings. Grounding bushings should be inspected periodically for signs of corrosion, damage, or loose connections. Any damaged or corroded grounding bushings should be replaced immediately. Loose connections should be tightened to the manufacturer's specifications. Furthermore, the grounding system as a whole should be tested periodically to verify that it is still providing a low resistance path to ground. This testing should be performed by a qualified electrician. By following these guidelines for selecting, installing, and maintaining grounding bushings, you can help to ensure the safety and reliability of your electrical system. Grounding bushings are a critical component in protecting equipment and personnel from electrical hazards. The National Electrical Code, or NEC, provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure that electrical systems are installed and maintained in a safe and effective manner. Grounding bushings are specifically addressed in several sections of the NEC. For example, NEC section 250.92b requires the use of grounding bushings or other approved means to bond metal raceways in enclosures containing service entrance conductors. This requirement is intended to ensure that any fault current that may occur on the service entrance conductors will be safely conducted to ground. Similarly, NEC section 250.94 requires the use of grounding bushings or other approved means to bond metal raceways and enclosures containing equipment grounding conductors. This requirement is intended to ensure that any fault current that may occur on the equipment grounding conductors will be safely conducted to ground. In addition to these specific requirements, the NEC also provides general requirements for grounding and bonding that apply to all electrical systems. These general requirements are intended to ensure that all metal parts of an electrical system are properly bonded together and connected to ground. By following the NEC requirements for grounding and bonding, you can help to ensure the safety and reliability of your electrical system. Grounding bushings are an important part of meeting these requirements. The selection and installation of grounding bushings should be performed by qualified individuals who are familiar with the NEC requirements and have the necessary skills and experience. A properly installed or selected grounding bushings can compromise the safety and effectiveness of the grounding system. In conclusion, grounding bushings are essential components in electrical systems, providing a low resistance path to ground for fault currents and surges. They are used in various scenarios, including connections to grounding electrodes, neutral conductors, and surge arresters. Proper selection, installation, and maintenance of grounding bushings are crucial for ensuring the safety and reliability of electrical systems. Adherence to the National Electrical Code requirements for grounding and bonding is also essential for maintaining a safe electrical environment.